Good evening, everyone. Am I audible? Am I audible, guys? If I'm audible, can you just give a thumbs up? Okay, I will just share my screen. Just give me a moment. Okay, so first of all, today's winner, everyone, please congratulate Srinivas Rao. Srinivas is the guy who solved all the problems in the minimum amount of time. He was the first person to solve all the problems which were given in the last assignment. Okay. Everyone, please congratulate Srinivas for this. Videos downloadable. Is there a feature in YouTube for that? Can we like, I'm not aware of that, but if there is a feature to make a video downloadable, we will do this. Otherwise, the video is always available on YouTube. So maybe you can use the feature of YouTube offline and save the video, right? Okay, so there was a problem in the assignment which I can see has been solved by very few students, right? So we'll discuss that problem because that is also a very important problem with respect to the interviews. Okay, the problem says that you're given an array and you have to find the pair that has got the minimum XOR. So out of all the numbers in the array, you have to find the pair of numbers which has got the minimum XOR. Did you guys attempt this problem in the assignment? So for example, if you have 1, 4, 5, 2, 3, if this is your array, you have to find the pair that has got the minimum solve. Okay, so now all of you who have already solved this problem, can you guys quickly tell me what is the best way to do this? In this case, the minimum XOR is going to be between 2 and 3, okay, which is going to be 1. Thank you, Hemant. Thank you for your appreciation. So you have to find the pair that has got the minimum XOR. Okay. Okay. SK Creations is saying that maintain a map with bit count of all the numbers. Okay. Uh, any other approach? Right. Sai, that is a correct observation. Okay. Now some of you are saying that sort the array first. Okay. why does sorting help here? What is the reason? Like most of all of you who have solved the problem have used sorting for solving this problem, right? But why sorting actually helps in this case? XOR of 4 and 5 is also one, correct. So that can also be an answer, but you have to return this value. So this value remains same in both the cases, right? So answer here is going to be 1. Okay. So let us say that you have to find the minimum, or let's say that you can return any of the available answers. So any of these two will be the answer. Okay. Let us not return the value. Let us return the pair. So any of these two will be the answer. Minimum elements XOR is minimum. Is that the case in this case? You can have the XOR of even the maximum elements is also minimum, right? XOR of 5 and 4 is also 1. XOR of 2 and 3 is also 1. But the minimum element here is 1, and 1 is not giving the minimum XOR with any of the elements, right? Okay, now to solve this question, we need to use a very, very important property of XOR, and then we'll make some observations. Okay, so a very important property of XOR that we studied in the last class, that if you are given a number A, then the XOR of A with A is going to be 0. Is everyone clear with this thing? XOR of A and A is always going to be 0, which means that if I have got a number which is repeating in this array, can I say that the minimum XOR will always be 0? If I have an array which has, let's say, which has a pair where the numbers are repeating. So if this is the array, what should be the answer? If this is the array, answer would be 4, 4, because this will always return 0, and we cannot have a XOR which is less than 0 if all the numbers are positive, right? So if I can find a number which is repeating in the array, then the answer is always 0, right? But what if there is no such number which is repeating? Let us again try to observe why this XOR is 0. Why the XOR of a number with itself is 0? It is 0 because at all the bit places, the value of digits in both the numbers is exactly the same, right? If I have 4 XOR 4, in all the bit places, this place, this place, this place, since both the numbers are exactly the same, these values are also same, right? That is why we are getting 0, 0, 0 at all the bit places. Okay. Now, just use this thing, and can you say by just looking at this that if the number are closer to each other, if the number are numerically closer to each other, then chances of having a lesser XOR will be maximized. The closer the numbers, the lesser would be their XOR. For example, if I'm taking XOR of 4 with 5 and versus XOR of 4 with, let's say, 16, this pair is going to give me a lesser XOR versus this pair. Does this observation make sense to everyone? Because chances of finding same bits are going to be lesser in the are going to be more in this case versus this case, right? Okay, now can I also say that since I want a value which is smaller in magnitude, right, which is smaller in the value, the most significant digit always decides what is going to be the actual value, right? Because if or the most significant bit is the one that decides whether the value is going to be larger or smaller than the other value, right? For example, if I have 4, right, and I have 8, the most significant digit which is set in 8 is here. The most significant digit which is set in 4 is here. The number which has got the most significant bit set on as left as possible is always going to be a number of higher magnitude, right? Because this is the bit with the highest power of 2, right? So to actually get a minimum XOR, we want to minimize the value of the most significant bit, correct? So we always want that the first set bit from left should come as late as possible, since we want to minimize this value, right? So the first set bit should be on as right as possible in the result. Does this observation make sense to everyone? So ideally, if I am given if I'm given a list of number, and if I select a number out of that list, and I want to find out what is the minimum XOR of that number with any of the given number, right? So if let's say I'm given a list of these numbers, and I select any random number, and I want to find out what is the minimum XOR involving this number, which number is going to give me the minimum XOR with this number b. Okay, so let us say that b has got this as the binary representation. Now a number which has the exact same binary representation, which means that if I have b again in this array, then this definitely is going to give the minimum XOR. But if b is not present, the next choice, what should be the next choice? The next choice would be that if I have a number which has just this bit as different, all the other bits should be same, right? This is the best choice that I can have if I don't have b again in the array, right? So in this case, the XOR is going to be 1. What is the other best choice that can I have? That what is the next choice? Next choice would be that the first different bit occurs here, right? Or if that is also not present, then I would say that the first different bit should occur here, and so on. So I want the first different bit to occur as right as possible. The first different bit with this number, if I have a number which has got which is different with b, different from b, and the different bit is occurring as right as possible, then that number is going to give me the minimum XOR, right? Out of all these numbers, whichever number is having the different bit on the rightmost side is going to give me the minimum XOR. Does this make sense? For example, if I list down some numbers, let us say I have 1 1 1 0 0 1 0 1, then I have 1 1 0 0 0 1 0 0, and then I have 1 1 1 1 0 0 0 1, then I have, let us say, 1 0 0 0 1 1 1 1, and then I have 1 1 0 0 1 1 1 0. Okay, now out of all these numbers, which number do you think is going to give the minimum XOR with this given number b? Let us try to analyze which number is having the different bit on as right as possible, right? So if you analyze this number, the different bit occurs here. Here we have 0 here, and in this number we have got 1, right? In this number, the second number, the different bit occurs here. You have 1 in the original number, you have 0 here. In the next number, the different bit occurs here again, right? In the next number, the different bit occurs here. In the next number, the different bit occurs at this position. Which of all these numbers is going to give the minimum XOR with the number? The last one, correct? Because here the different bit is occurring on as right as possible, right? If you take XOR of the first number, the result will be having the third bit in the result from left is going to be a set bit, so the magnitude will be very high. Here the fourth bit from right is going to be the this is going to be the set bit in the result, right? So again, the magnitude is going to be higher with as compared to this number. If you take a XOR with this number, all these bits in the result are going to be 0 because all of them are exactly same as the original number. This is the first bit which is different. That is why this is going to give you a set bit. Okay, so this is the idea behind this approach, right? You have to make sure that you are taking the XOR of a number with that number which has got the first different bit on as right as possible. Okay. Now, how can we do this? So intuitively, this comes to the mind that since all the bits from left to right should be same, right? Should be we want the maximum similarity between the numbers. So now, the closer the numbers, the more chances we are going to have in the similarities of the bits, right? The more close the numbers, uh, the the farther we'll find the different bit. Correct. Okay, so Himanshu has an observation: minimum difference between two number will give the minimum XOR. Is that correct? Now, there can also be a contradiction to this. For example, you have numbers like 8, 10, and let's say 7. Okay, what is the minimum difference between these three numbers that we can have? We have 8, 10, and 7. 8 is 100, 10 is 1010, and 7 is 111. If you are just checking the minimum difference, then you will be selecting 8 and 7. What is the XOR between 8 and 7? The XOR between 8 and 7 is going to be very large, right? This is going to be 15. So this observation can have some exceptions, right? But the observation that we made, earlier is that we want all the digits. We'll be checking for each and every number, and for each and every number we'll be considering the XOR. We'll be considering the XOR with that number which has got the first different bit as right as possible. Okay. So if you are considering the XOR with 8, you have got two prospects, right? Which of these two has got the first different bit as right, more on the right side? 7 has got a first different bit on the first bit itself. So 7 is not the contender with 8. Okay. 10 has got two similar bits. So 10 is a contender with 8. If you take XOR of 8 and 10, then you will be getting 2, right? So 8 will be giving the minimum XOR with 10. Then you will be checking what is the minimum XOR involving 10. So again, for 10 as well, 8 is going to be the prospect pair. And for 7 also, 8 is going to be the prospect pair, right? And then the XOR of the minimum XOR involving 7 is going to be 15, but we will select whatever is the minimum out of all the pairs, right? Now, if this thing is failing here, that the minimum difference is not giving the minimum XOR, then how is sorting helping here? Right. So if you are clear with this observation, right? If you are clear with this observation, XOR of any two consecutive numbers after 1 and 2 always gives us 1. No, Tuhina, I just gave you an example, right? 8 and 7 are consecutive numbers and they are not giving 1. This is not 1, this is 15, right? So the observation that you are making can be correct only in those cases where you are not incrementing, you are not adding a new digit, right? So if you are switching from a number which is of the form 2 raised to power n minus 1 to 2 raised to power n or 2 raised to power x, in that case you will be getting a very large XOR value. Okay. Okay, so how to solve this problem? Now, the intuition that comes to the mind is the closer the number, the more similar bits we are going to get on the left hand side. Okay. If you sort all the numbers, if you just sort these numbers, you get 7, 8, and 10. Right? The intuition is the closer the numbers, the lesser the XOR. However, we have seen an exception of this, right? But if you sort these numbers, now I can say that 8 will either give a minimum XOR with 7 or 8 will either give the minimum XOR with 10. So these two are the only numbers with which 8 can give the minimums. Or let us say that we had more numbers in the array. If you also had 5, 3, 12, and 15, if you have all these numbers, even then I can definitely say that the XOR that 8 is giving with 7 is always going to be smaller than the XOR that 8 gives with all these numbers. And the XOR that 8 gives with 10 is going to be smaller than the XOR which 8 is going to give with all these numbers. So 8 is always and always going to give the minimum XOR either with 7 or with 10. Okay, does this make sense to everyone? Because out of these two, one of them is going to have the maximum number of similar bits on the left side. Okay, that is why if you sort all the numbers, and you just check the XOR of all possible pairs, you will be getting the minimum XOR out of all the possible pairs. Because 8 can only give the minimum XOR that involving 8, the minimum XOR that which you are going to get involving 8 is going to come either from 7 or from 10. It will not come from these numbers. Why? Because these two are the closest to 8. This one is the closest on the left hand side, this one is the closest on the right hand side. And we have seen that to get the minimum XOR, we want all the digits on the left hand side similar to the given number, right? Is it clear now? How 7 and okay, 7 and 8 are not giving the minimum XOR. Try to understand this thing. How are you actually going to find the minimum XOR? Think about the brute force approach. The brute force approach would be, if you don't just skip all these things which we have discussed till now. What is the brute force approach of doing this? The brute force approach is that for every number you take XOR with each and every other number, right? And you store that in a variable minimum. If you find the minimum XOR, then you store that in a variable. This is going to cost you order n square time, because for every number you are going to take the XOR with every other number, right? This is going to be an n square approach. Now what I am saying is that you don't need to take XOR of 3 with each and every other number. You can only take the XOR of 3 with two numbers, one which is closest on the left side, one which is closest on the right side, and the minimum of that two is going to be the minimum XOR that 3 can give you. Okay, so in this case, if you are looking for what is the minimum XOR involving 8, right? What is the minimum XOR involving 8? If you want to find that out, if you are doing a brute force approach, you will be checking 8 XOR 3, 8 XOR 5, 8 XOR 7, 8 XOR 10, 8 XOR 12, 8 XOR 15, each and every number, right? But I'm saying that you don't need to do all of these things. These all calculations are totally needless. Why? Because we have seen that if the number of bits are similar on the left side, right? I want to find the number which has got a different bit on as right as possible. I can say by intuition that the closest number are going to give me that. So 8 XOR 3 will always be greater than 8 XOR 7, because 7 is closer than 3, right? Similarly, I can say that 8 XOR 10 will always be minimum than 8 XOR 12. Okay, because again 10 is closer to 8 than 12. So chances of having different bit is going to be more on right side for 10 rather than 12, right? So this is the intuition behind this, that you sort the numbers and then you just check for every number, you just check with the adjacent numbers. So for 5 you will be checking with 3 and 7, for 7 you will be checking with 5 and 8, for 8 you will be checking with 7 and 10, and so on. Okay, is this clear to everyone now? Or should we also try to prove this mathematically? Okay, if you are not convinced with the intuition, let us try to see a mathematical proof behind this. Okay. So let us say that we have got two values A and B. Okay. And I'm saying that A is smaller than B. Okay. If A is smaller than B, then there are some bits for which the value is same in A and B. And then this is the first bit with in which the value is different in A and B. Okay. If A is smaller than B, and this is the first position where the bits are different, what can I say about the values? Can I say that A will always have 0 and B will always have 1? Yes, no, right? Because A is less than B, and this is the first bit at which A and B are different. All these are exactly the same, whatever be the value. This is the first bit where these two numbers are different, right? So so we can definitely say that A is going to have a 0, B is going to have a 1. Okay. Now, if you put another value between these two, okay, if there is another value between A and B, let us call it X. So A and B are not consecutive, but A and B are just two values in the array. And now we insert a value X here, okay. And X has got a value between A and B, okay. So I can say that A is less than X, which is less than B. This is the relation, okay. What can we say about this bit in X? Is it going to be 0 or 1? It can be anything, right? It can be 0, it can also be 1. X, this bit can be anything, right? It can be 0, it can also be 1, right? Because these bits are same in A and B, we are not sure about what is there in these places in X, right? So X can have a 0 here, X can also have a 1 here, right? Now, let us consider both the cases. Let us consider a case where X has got uh, a 0 in this place, and the other case where X has got a 1 in this place. Okay. Now, if I take XOR of all the pairs out of these three numbers, which one do you think is going to be the lowest? Which one out of these three pairs is going to be lowest? Can I say that the XOR of A and X will always be lower than the XOR of X and B and the XOR of A and B? Yes, because A and X have got 0, 0 here. So the first different bit is going to be after this, right? Correct. So this is going to be the smallest. If X has a value 1 in this case, then can I say that X XOR B is always going to be less than A XOR X and X and A XOR B? Yes, because in this case, these two are going to have the same bit at this position and rest all the bits are same, right? So they will have the first different bit on more left right side, correct? So in any case, whether X has got 0 or X has got 1, we can see that we are always finding the minimum XOR between the adjacent pairs, between the closest pairs, right? Is this clear now? So now we can say with a proof that the closest XOR or the minimum XOR occurs between the closest element. So if you have got an array, you can just sort the array and you can just check the XOR of the consecutive numbers. Okay. Should we move to the next problem now? Okay, let us now try to solve a problem which was asked in Google Code Jam. Okay. So the problem says that you are given a distributed system. This was asked in Google Code Jam 19. Okay. The problem says that you are given a distributed system where you have a master server. Okay. And this master has got multiple slaves. Are you guys familiar with the master slave architecture? If you are not, I would recommend all of you to go and read about what is master slave architecture. Okay. So you have got this system where there is a master server and there are slave servers, but the job that is given to these servers is very trivial. You are entering a binary string in the master server. Okay, a random binary string is entered in the master server, and since the master server, this is a server which cannot store the things. So what it does, it sends one bit to every slave server. Okay, so if let's say if there are 4 slave servers, okay, so if you have one master server and then you have got 4 slave servers, so then in that case you will be entering a binary string of length 4. Okay, and the master server, it distributes each and every bit to one server. So 1 goes here, 0 goes here, 1 goes here, and 1 goes here. Then after a while, master server asks all the servers to return these values so that it can return the string to the user. So S1 returns 1, S2 returns 0, S3 returns 1, S4 returns 1. Okay. Now, the problem here is some of the slaves are faulty. Some of the slaves are not working properly. So let us assume that if S2 is a faulty slave, it is not working properly. In that case, S2 will not be able to return this bit. So S2 will not return anything. Okay, S2 is not getting the instructions to return, so it will not return anything. So if S2 is faulty, when master asks for the string, he will only be getting 111 because 0 is gone now. Okay. If S2 and S3 is also faulty, in that case you will only be returning 1 and 1. Okay. If S3 and S4 are good, but S1 and S2 are faulty, in that case also you will be getting 1 and 1. Okay. So any server, which server is faulty is not going to return anything. Is the problem clear to everyone? Or is the scenario clear to everyone? You have a master server and you are just inputting a binary string of length n, where n is the number of slave servers that you have. Master server distributes each and every bit in the exact same order to all the slave servers and then asks for the bits to create the string again. Okay. So if the slave servers are faulty, they do not return anything. Okay. You have to identify, given the number of slave servers, you have to identify which of these servers are faulty servers. Okay, you are only given the number of slave servers. Identify the faulty servers. Is the problem clear? Will we be given the final string? Yes. So what you are given is that you can input any string. You can input a string of length n. So let us say that you are given two functions, read and write. Okay. This is a function write, which takes a string, a binary string of length n, and you have got a function read, which returns a binary string. The length can be less than or equal to n. So here the length should be exactly equal to n. Here the length will be less than or equal to n based on how many servers are faulty. Let us take an example. So let us say that number of slaves is 4. Okay, and out of them, so you have got 4 slaves, and out of them slave 4 is the faulty slave. This is the, so this is not given to you. You are only given that there are 4 slaves, and these two functions are given to you. Using these two functions, you have to identify which slave is the faulty slave. Okay, so if you enter a string, you just say write 1101. If this is the string that you enter, and after this, if you call read, right? If you call read, then the string that you get is 110, because slave 4 is faulty and this one will not be returned. Okay, if again you call write 1100, in this case, if you do read, you will be getting 110, because slave 4 is faulty, so you don't get this. Okay, any number of slaves can be faulty. There is this is not given that only one slave is faulty. Any number of slaves can be faulty. It might be possible that slave 3 and slave 4 both are faulty. In that case, you won't be getting the last two bits of your string. Okay, this is multiple answer question. No, Akshay, this is not a multiple answer question. This is a this is actually supposed to be a coding question. This in Google Code Gen, you are supposed to code this question. Okay, Deval, that is in the right direction. What is the time complexity of your approach? At least one slave will be working. It might be possible that all the slaves are faulty, although you will get to know that in the first read call itself. But it is possible that all the slaves are also faulty. If they are faulty, they never return anything. Okay, we need to return number of faulty slaves or name. No, you have to return the names, because number is definitely clear in the first call itself, right? You can just subtract the length of the output from the length of the input, right? So number is clear in the first call. You have to return the names of all the faulty slaves. Okay, Deval, that is correct. Can you optimize that? Okay, now the question is, can we compare the bits and check the missing one? Okay, let us take a bigger example. Okay, if this is, if we are talking about only 4 slaves, then this looks kind of obvious, right? If there are 100 slaves, if there are 100 slaves and you are sending a string of size 100, okay? And in the output, let us say you are getting a string of size 81. So this has got 100 length, okay? And in the output, you are getting a string of size 81. How do you recognize which all 19 slaves are faulty? Because they can be the first 19, they can be the last 19, or they can be the 19 in between. How do you compare? You have got a string of length 100, you have got another string of length 81. How do you compare these two strings? Are you comparing this one with this one and you are saying that the first slave is correct? It might be possible that this first slave is not correct, right? Let us take another example. Let us say that you input all one. Okay, if the input is all one and you send 100 ones, and then you are returning, you are getting in return 81 ones. These are 100 ones, and then in return you are getting 81 ones. How do you find which 19 slaves are not working? Take XOR of the return string with the original string. What will that return? So, Preeti, are you getting the problem in the first place? The problem is that you have to you don't have to identify the count of the faulty slaves. You have to identify the names, right? You have to tell that S1 is faulty or S4 is faulty. Now, if you are comparing and you are saying that this one is correct, which means S1 is not faulty, it might be possible that at S1 was faulty and this input has this output is from S2 or S3 or S4. Yes, an image that is in the right direction. That is correct. That can be one of the solution. Okay, what could be the brute force solution here? Can you guys suggest a brute force solution? Devil has already suggested. You have got n slaves, okay? And you don't know how many of them or which of all these slaves are faulty. The brute force solution is check each and every slave one by one. If you input this string, right, where you have a single bit as a set bit and then all other as unset, and then if you input this, you know that the set bit is going to the first slave. This bit should be stored in the first slave. All the other bits are 0. When you read, you just have to make sure whether there is one bit set in the output or not, right? So you write this number where you have 1 and then rest all n zeros, okay? And then you do a read. If read returns a binary string of any length which has at least one bit set, can I say that S1 is not faulty? Or if read returns a string which has got all 0, can I say that S1 is faulty? Yes, because I am sending only one set bit which should go to S1, and when I do the read, it should be returned from S1. If I'm not getting any set bit, this means that S1 definitely is faulty because there was only and only one set bit in this, right? Battery 12%. I think that is sufficient. 12% battery is okay. Okay. What if we send all 0 bits? Srinivas, you will not gain anything from that, right? If you are sending all 0 bits, there is no identifier, and then you return, then you get, let's say, 3 0 bits in return. What do you gain? You don't gain anything, right? You only know that there are 2 bits which are slaves which are faulty, but you don't know which one. But if you are sending this string, and in return, let's say you are getting three unset bits, one thing you know for sure is that S1 definitely is faulty because there has to be at least one set bit in the output if S1 is not faulty. So this, if you send this string, you can make a decision whether S1 is faulty or not. Okay. Similarly, if you send another string of the same kind, so this is just to check whether S1 is faulty or not. Similarly, to check S2, you can set the second bit and keep all the remaining bits as unset, and then this will check whether S2 is faulty or not, because in the return in the output that you are getting, if there is no bit which is set, then you are sure that S1 is faulty, because the only set bit was sent to S2, and if it is not getting returned, then S2 definitely is faulty, right? Similarly, if you want to check S3, you can set a set bit in the third position. If you don't get the third bit as set, you can definitely say that S3 is faulty. Now, does this make sense to everyone? Correct. Yes, Suji, that is totally correct. How many queries we will have to do? What is the total number of queries if you are going to go by this approach? Or what is the time complexity? For every server, for every slave server, we are doing a different query, right? For every slave server, I'm trying a different string, which means that for every slave server, I will have to do a query. So I will be doing exactly n queries. So time complexity becomes order n. Okay, correct. N is the number of slaves. Correct. Now, can we optimize this thing? Can we do this in less than n queries? Okay, now some of you have got some optimizations. Some of you are saying that let us set 2 bits one, and now you can just check whether the first is set or the last is set. Based on this, you can decide on 2 servers at once, right? This might also work. You can actually every query can give you output about 2 servers. But let's say if there are only 2 servers, S1 and S2, and if you give this as the input and you are getting 1 in the result, how do you know whether S1 is faulty or S2 is faulty? So this again is going to have some edge cases which you will have to deal, right? Okay, now guys, if let us say that some servers are faulty, right? Let us say that we have got 4 servers, or let's say we have got 5 servers. We'll make a very interesting observation here. Okay, if we have got 5 servers, out of which S2 and S4 are faulty, these two are the faulty servers, rest all are correct. Okay, these two are the faulty servers. Now if I am writing a string 11111, what is the output that I'm going to get? Can you guys quickly write outputs with me? The output that we are going to get is S2 and S4. These two will be missed out. So the output that we get is 111. Okay. Then if I enter another number, let's say 10101, what is the output that we are going to get? We are going to get 111. If I add another number, uh, if I input, let's say 10000, what is the output that we are going to get? We get 1 and then 00, right? If I enter 00111, what is the output that we get? We get 0 and then 1 and then 1. Are you able to observe one thing, that in all these input, since S2 is faulty, this whole column is missing from the output, right? The first column is present as it is, right? 1110, this column is present as it is. Second column is completely missing. Third column is again present as it is. Fourth column again is completely missing. So we have got two voids in the output, right? Rest everything is totally correct. First column is totally matching. Second is totally gone. Third is matching. And then fourth is gone. Fifth is also matching. Correct? Can I use this column to uniquely identify a server? Vignesh, that is also a correct approach. Using binary search will also solve this problem, right? So can we use this column which is missing to uniquely identify a server? What if I create a pattern in such a way that this column is representing a number? Okay, because this is my input and this is my output. Okay, if I can somehow make sure that this whole column is meaning something, this is giving this is, if let's say this becomes a unique identifier, this is representing the ID of that slave, right? So for example, if I number these slaves from 0 to 4, okay, and now I just give in input, I give the input such that the first column is always going to have all 0 values, okay. Then the second column is always going to have values in this order. The third column is going to have values like this, and the fourth column is going to have values like this, and then the fifth column is going to have values like this, okay. If I send the input in this order, right, what will be the output? If I'm sending the input in this order and slave S3, S2 and S4 are empty, this is the first string. The output that I get is 0, 0, 0. Then in the next one, the output that I get is 0, 0, 1. Then the next output is 0, 1, 0. And then the next output is 0, 0, 0, right? Again, this whole column is missing from here. And this whole column is also missing from here, right? What does this number represents? What is this number in decimal? If you consider this first column as a binary string, what is the representation of this number in decimal? This is nothing but 0. What is the representation of this number in decimal? This is nothing but 1. What is the representation of this number? This is again nothing but 2. This is 3. This is 4. Okay. In the output, what are you getting? In the output, you are getting the first column, which is representing 0, which means slave 0 is totally fine, right? We had sent all these strings in a way that each and every column is making a pattern which can be used to uniquely identify all the slaves. If I'm sending all zeros in the first column, this means that this is for slave number 0, right? Then I am using the second column to uniquely identify the first slave. I am using the third column to uniquely identify the second slave. If a column is missing, I know that a number is missing. So I have 0 here, I have 2 here. This column is representing 2. I don't have 1 here, right? I don't have 3 here. I then have 4. So now I can say that the slave which is numbered as 1 and the slave which is numbered as 3, the 1 and 3, they both are faulty. Does this make sense to everyone? So we are using the bits to uniquely identify the numbers, and we are actually creating a mask of these bits, right? If two columns have same numbers, is that possible? Will two columns ever have same numbers? Can you have two numbers which have the exact same binary representation? Can you have two numbers which can have exact same binary representation? No, that is not possible, right? So no two columns are going to have same value. Okay. Now the question is, how many queries we'll have to do? If you go by this approach, how many queries are required? Just pay attention that these are not the queries. This is one query. This is the other query. This is the third query. This is the fourth query. How many queries are required? In this case, to get how many queries are required, just again observe what we are essentially doing. We are representing each and every slave in binary form, right? So the length of the query is equal to the number of slaves, but the number of queries that we are making is equal to the number of bits which are required to represent these numbers in binary, right? How many bits do we require to represent a number n in binary? How many bits are required to represent a number n in binary? Exactly log base 2 n bits. So how many queries do we need to send now? We need to send exactly log base 2 n queries. Okay, if there are 1,000 slaves, how many queries do we need? If there are 1,000 slaves, what is the number of bits in which we can represent 1,000? We can represent thousands inside 32 bits, right? So you don't need to send more than 32 queries. In the initial approach, we were sending n queries. That means for 1,000 bits you were querying it how many times? Sorry, for 1,000 bits you can actually do it in 10 digits, right? 2 raised to power 10 is your 1024. So any number less than equal to 1024 can be represented in 10 bits. So if you have got 1,000 slaves, then you can do it. You can find the faulty slaves only using 10 queries. In the initial approach, you were doing 1,000 queries, right? Okay. So does this thing make sense to everyone? Now there is another approach to solve the same problem which some of you have already written in the comment section. You can also solve this using binary search. Okay, we can maybe reiterate over this when we do binary search classes. But I would recommend you guys to think about that. Okay, you can maybe have this type of a pattern where you separate ones and zero, and now you can count how many faulty slaves are present in the first half, how many faulty slaves are present in the second half, and then you can do the exact same thing in the first half, and then you can do the exact same thing in the second half, and you can again find out how many faulty slaves are there. Okay, so that is another approach using binary search. You can try to think about that approach yourself. But is this thing clear? Okay. Pseudocode. Did you get the idea, Shubha? If you get the idea, you can just Google this problem. You can Google, or maybe we can post the link in the chat group. The problem where it was asked in Google Code Jam, and then you can attempt it there. Okay. Thanks a lot, Himanshu. Thanks a lot, guys. Okay, so now I will end the session. Tomorrow onwards, we'll be starting lectures on, no, tomorrow we'll be having a lecture on 2 pointers, problems based on 2 pointers. And then after that, we'll be doing classes on searching. Okay, so I hope you learned something in today's lecture. The last 1 hour was useful for you. If you find it useful, please do like the video. And if you want any topic to be covered, please write that in the comment section. Okay. Thank you guys. Thanks a lot. Good night.